This is sodium chloride or
This
potassium
is the
chloride.
sodium chloride, this is the distilled water.
Potassium chloride.
There's some quickfall on the bottom there.
Potassium.
You want to?
Okay. That's it.
There's some white
So,
crystal.
and this is how it works.
Yes.
You connect this thing, and you have two pumps. A for the water, B for the potassium chloride solution. You connect the water tank, and in this meter, you measure conductivity. You see? That's the conductivity meter. No? So, you take samples about 10 seconds, 20 seconds. You see? So you measure a sequence of values. No? So, at the beginning, pretty soon you will see that the conductivity will level off. Okay? And it was very low. No? At time equals 0, when you start really the experiment, you switch off the water and switch on the salt. Okay? So what will happen? In that particular way, what it will create is a step disturbance. Remember, the ideal step goes like that and then boom, and then remains constant. That's the ideal one. Now you're going to see how a real step works. The real step will work like this, slowly, 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 until after about 5-10 minutes, with which is the constant value on the top.
So doctor, from the onset, the 2 pumps are on, or
Now, the onset only
only the potassium?
only the still water part. Okay? So you switch it, that thing off, and switch the other in. Okay? You see? So basically you can compare a theoretical step against a real step. You see? Because we don't carry out experiment. Okay, we cannot connect it and all these things that we don't like it. Okay? So I will give you a set of data from the people who do this. You have something to write on? One is the concentration of the salt is the infinite concentration, the one when you get to the final value of the step, you see, times 1 minus the exponential of minus t, that is the time, divided tau, that is the characteristic time of the process. Okay? So you're going to have a set of time, conductivity, concentration values. No? Those are experimental data. You have to try to fit a function like this, and you will have two aims there. First, to see how well your data fits something like this, and the second, if you fit more or less, try to find out this characteristic time. You see? That's how you're gonna do it. No? That's for the step. For the poles, what you do is everything is stabilized again. You connect the distilled water. So you got, after about 10 minutes, you have a flat line. So at time equals 0, now you disconnect the distilled water, you connect the other. Okay, like you did before. But you keep it only for 20 seconds. After 20 seconds, you disconnect this and you connect the other. So basically, what you have done is you have injected a pulse. Okay? The pulse will be something like this, you know, like a triangle, and the area within the triangle will be a symmetric area within the triangle will give you the mass injected in those 20 seconds. Okay? So you keep going, you know, you do like this after the 20 seconds. The salt off, and the other on, okay? And then you will see how the real poles look like. Not gonna be symmetric at all. Will start later than the real poles will be like that, with a long tail. See? So in that particular case, what you do is you just more or less plot the theoretical, calculate the area. Okay? So remember that is concentration versus time, and you're supposed to know the flow, so you can more or less figure it out. Okay? Remember, the time is 20, the base you have.
20 seconds.
Yes, 20 seconds. No? So, and then you need to compare with the other, okay, the real concentration. So basically you compare the theoretical poles against the real poles. See? In this particular case, the function is complicated. You can try to fix something, but you're going to get a polynomial passing through those. See? So that will not be good. Watch out for this. So, you see, that's what you need to do. I will give you the values now, so we don't bother these people too much, and we don't distract their labs. So let's get it in again. That's why we call it the ghost experiment. Okay? So we don't need to pay anything.
You guys take a picture.